Hello everyone. Welcome back to Roadmap to JEE Advanced 2026, episode 4, How to Tackle Integrals. So in the previous episode, we have seen some questions and two categories, right? So let's continue with that. Let's take the first question for this video. This is a question from JEE Advanced 2017. Now, once again, here, this is a question based on creating upper and lower bounds for the given integration here, because you have to check whether I is greater than or less than log 99 or I is greater than or less than 49 divided by 50 here. So, which means obviously it's a question based on creating upper and lower bounds. So, let's see how to solve this kind of questions here. First thing, I'm going to do something like this. We know that definitely x will be less than x plus 1, and if I multiply both sides by x plus 1, I will be getting x into x plus 1 less than x plus 1 whole square. That is nothing but 1 divided by x into x plus 1 greater than 1 by x plus 1 whole square. Okay. Now clearly we want k plus 1 also, right? So since I know that 1 by x into x plus 1 greater than 1 by x plus 1 whole square, if I apply integral k to k plus 1 k plus 1 of dx divided by x into x plus 1 on both sides. So this will be again greater than integral k to k plus 1 k plus 1 multiplied by dx whole divided by x plus 1 whole square. So clearly you have created the lower bound for this integration, right? Now let's try to solve this one because this is easier to solve here. Directly k plus 1 is a constant, so this is greater than k plus 1 is a constant multiplied by integration of 1 by x plus 1 whole square will be minus 1 by x plus 1, and where limits are from k to k plus 1. So I will take that minus outside. So minus of k plus 1 multiplied by, if I substitute the upper limit, this will be 1 by k plus 2 minus of 1 by k plus 1. Or else I can write it like this also. This is greater than k plus 1 multiplied by, if I take that k plus 1 minus outside, this becomes 1 by k plus 1 minus k plus 2. Okay. Now, if I take LCM and cancel out k plus 1, the only remaining part will be 1 divided by k plus 2. So, this is integral k to k plus 1 of k plus 1 dx divided by x into x plus 1, that is greater than 1 by k plus 2. But we need sigma to this one actually. So we have to calculate sigma k is equals to 1 to 98, right? So let's do that. Sigma k is equals to 1 to 98, and right hand side also sigma k is equals to 1 to 98. Now observe this thing clearly here. What I can do is, this is greater than, if I start expanding here, I will be getting something like this: 1 by 3 plus 1 by 4 plus 1 by 5, and then so on up to 1 divided by the last term is going to be 100. So totally how many terms are there here? Exactly 98 terms are there. But we can't calculate the sum of all these values, right? Instead, what I am going to do here is, I can say that this 1 by 3 will be definitely greater than 1 by 100. Similarly, this 1 by 4 is also greater than 1 by 100, and so on. This 1 by 99 also will be definitely greater than 1 by 100. So which makes this entire expression obviously greater than 1 by 100 plus 1 by 100 plus so on up to 1 by 100. And how many terms are there? 98 terms are there. So that is why that should be greater than, whereas this is given as capital I, right? So that is why capital I greater than 98 divided by 100, which would be 49 divided by 50. So we created the lower bound, which is I greater than 49 divided by 50. Okay. Now to create the upper bound, the trick I'm going to use here is, we know that x is greater than k because the integration limits are from k to k plus 1. So x is greater than k. Now I'm going to add 1 to this, x plus 1 greater than k plus 1. Now I'll divide both sides by x into x plus 1. So x plus 1 divided by x into x plus 1 greater than k plus 1 divided by x into x plus 1. So that once again we got this required part, k plus 1 divided by x into x plus 1 is less than 1 by x, but we need the integration of this from k to k plus 1. So integral k to k plus 1 dx, here also integral k to k plus 1 dx. Now you see the advantage, right? because this right hand side part is easily integrable. So let's do that. So this is lesser than ln of x, where limits are from k to k plus 1. And if you substitute the limits, you will be getting like ln of k plus 1 minus of ln k, log a minus log b, which would be log of a by b. That is ln of k plus 1 divided by k. So this is the right hand side part. But once again, we need to apply sigma to this one, right? So let's apply sigma. That is sigma k is equals to 1 to 98 integral k to k plus 1 k plus 1 dx divided by x into x plus 1 will be less than sigma k is equals to 1 to 98. The right hand side part is ln of k plus 1 divided by k. Now if you start expanding the right side, you would understand how to create the upper bound. Because if you put the k is equal to 1 value, you will get log 2 by 1 plus next value will be log 3 divided by 2 and so on up to what's the last value here, log of 99 divided by 98. But if you add up everything, we get it like log of 2 by 1 into 3 by 2 into 4 by 3 into so on up to 99 divided by 98. So clearly all these terms would be cancelled out. Only remaining part will be log 99 to the base e. So clearly this is I. So what we can say is I will be lesser than log 99 to the base e. So which is option B here. I will be lesser than log 99 to the base e. Moreover, we have already got I greater than 49 by 50, right? So option D. So this is how you have to create upper and lower bounds for the given integrations, and then we need to simplify. Okay, so this is one multi-conceptual question, right? So we have seen two categories till now. The first one was pattern recognition and second category was multi-conceptual. Now the third and most important category is property based here. So students have to concentrate here because this is a scoring part for many of you because this is relatively easier to compare to category 1 and category 2. So let's start looking at the questions in this category. Let's take the first question in this category. This is a question from JEE Advanced 2024. Two functions f of x and g of x are given to us, and we need to evaluate 2 into integral 0 to pi by 2 f into g minus integral 0 to pi by 2 g of x dx. Okay. So the main thing in this question is you need to analyze the first integration here. So let's take it as some capital I. Capital I is equals to integral 0 to pi by 2 f of x. F of x here is nothing but sine square of x multiplied by g of x will be square root of pi x by 2 minus of x square. Let me take it as equation number 1. Okay. So many students might think that we need to solve the two integrations separately and it's going to be a very lengthy process. But the beauty of this question is you just need to use the King's rule here. So we know what is King's rule. You can simply replace x with a minus of x here. That is replace x with pi by 2 minus of x. Okay. So let's see what happens. We get capital I is equals to integral 0 to pi by 2. Sine square x obviously becomes cos square x if you replace x with pi by 2 minus of x, and let's calculate the remaining part. Square root of this is pi by 2 into, in the place of x I am putting pi by 2 minus of x, and minus of again this is pi by 2 minus x whole square. Okay, now let's expand and see what happens here. This is pi square by 4 minus pi x by 2. Minus of pi by 2 minus x whole square would be obviously pi square minus pi square by 4 minus x square plus 2 into pi by 2 into x, that is pi x. So clearly these terms will be cancelled out, and once again pi x minus pi x by 2 will be nothing but pi x by 2 minus of x square. So which means on resolving this entire part, you get pi x by 2 minus of x square. But what's the main advantage there? That is exactly what is there in the equation number 1 already. So if you want, I can write down one more time. I is equals to integral 0 to pi by 2 cos square x into square root of this will be pi x by 2 minus of x square. Now you can take it as equation number 2. Simply add both of them. Equation 1 plus equation 2 will give you 2 times of I is equals to integral 0 to pi by 2. So when you add these two, clearly the square root part is same in both of them, right? So let's take common square root of pi x by 2 minus x square and multiplied by sine square x plus cos square x, right? On taking common, But we know that the sine square x plus cos square x is clearly 1 here. So what's the remaining part now? 2 into I is equals to integral 0 to pi by 2. But what is actually square root of pi x by 2 minus x square? Nothing but g of x. So 2 into I is equals to g of x dx. Now look at the required part. What we want is 2 times. So I have taken this as I. So 2I minus of integral 0 to pi by 2 2I minus of integral 0 to pi by 2 g of x dx. This is the required part. But already we have got 2y is equals to integral 0 to pi by 2 g of x dx. So which means both of them will be cancelled out and the result is 0. So this is how the property based questions based on definite integration will be asked. So if you are perfect with the properties, you can score easily. So as I told, this is the reason this category type of questions are the scoring part for many students. Okay. Now this is a paragraph question actually. This is only the first question of that. And the second question is this. We have to find out the value of 16 by pi cube into integral 0 to pi by 2 f of x into g of x. Now the main thing is if you solve the previous question, now this is going to be easy because when you solved it, you got 2y is equals to integral 0 to pi by 2 g of x dx, right? So whereas I is nothing but 1 by 2 into integral 0 to pi by 2 g of x dx. But what is actually I that we have taken integral 0 to pi by 2 f of x into g of x. This is what we have taken as I. So that we have got it as 1 by 2 times of 0 to pi by 2 g of x dx. So now I'm going to make use of it here. So the required part becomes 16 divided by pi cube multiplied by, now from the previous question we have done already, integral 0 to pi by 2 f into g is nothing but 1 by 2 times of integral 0 to pi by 2 g of x dx. Now clearly 2 will be cancelled out and remaining part will be only 8 divided by pi cube integral 0 to pi by 2. What is g of x function here? Square root of pi x by 2 minus of x square. Now it is a clear direct formula based now because it's a property, right? So if you want, I can recall the property for you. That is, whenever we have integral square root of a square minus x square, it will be is equals to x by 2 multiplied by square root of a square minus x square plus a square by 2 into sine inverse of x divided by a. So this is your integration for square root of quadratic. So clearly you have square root of quadratic here. The only thing is you need to convert this into a perfect square form, but you know how very well how to convert this one, right? So this pi x by 2 minus x square is nothing but pi by 4 whole square minus of x minus pi by 4 whole square. So I'm going to substitute that here. 8 divided by pi cube of integral 0 to pi by 2. This is square root of pi by 4 whole square minus of x minus pi by 4 whole square. Now just look at the formula and substitute it. That is 8 by pi cube multiplied by, now what is the integration? X by 2. X is nothing but here x minus pi by 4 divided by 2 into square root of, this will be a square minus x square, that is pi by 4 whole square minus of x minus pi by 4 whole square, where limits are from 0 to pi by 2 plus a square by 2. Here clearly a is nothing but pi by 4, right? So a square will be pi by 4 whole square divided by 2 into sine inverse of x by a. X here is x minus pi by 4 and a is nothing but pi by 4. So once again limits are from 0 to pi by 2. Now you know what to do. Substitute upper limit, substitute lower limit, and I hope you can do the remaining calculation part here. So as you can see, if you remember the formula of integral root of quadratic here, this is a very easy question. So as I told, once again I'm reminding you, all these questions are directly based on property, which means you must remember the properties and also formulas of integrations here. And as you can see, this is a question from direct 2024 JEE Advanced, a paragraph, so which would almost carry 6 marks here, both the questions combined. Okay, let's take the next question. Again, this is a question from Advanced 2021. Once again, a paragraph question. And once again, it is a complete property based question. So which means high scoring chance, right? So let's analyze two functions are given g1 of x and also g2 of x here. And they have given you a value si, which is integral f of x into gi of x here. Okay. Now the first thing is I have to calculate 16 by pi into s1. So let's write down s1. What is s1? Integral pi by 8 to 3 pi by 8 f of x multiplied by g1 of x. Putting I is equals to 1 will give you s1. So let's substitute the functions also here. This is nothing but integral pi by 8 to 3 pi by 8. F of x is already given to you, which is sine square x in the question, right? But what is g1 of x here? 1. Okay. So which would mean you have s1 is equals to integral pi by 8 to 3 pi by 8 sine square of x dx. Okay. Now, after this step, many students might go for this process here, writing sine square x as 1 minus cos 2x divided by 2. Okay, so this is a time wasted process. That is, many students write this as sine square x as 1 minus cos 2x divided by 2. Don't do that, it will take some time. Instead, use the King's rule, that is, you can replace x with pi by 8 plus 3 pi by 8 minus of x, because we have the property replacing x with a plus b minus of x. So what is pi by 8 plus 3 pi by 8? Clearly 4 pi by 8, that is pi by 2. So you just need to replace x with pi by 2 minus of x here. So if I take this as equation number 1, again s1 is equals to integral pi by 8 to 3 pi by 8. Now if you replace x with pi by 2 minus of x, sin square x will change to cos square x dx. Now this is equation number 2. Clearly add both of them, directly you would get 2 times of s1 is equals to integral pi by 8 to 3 pi by 8. Now remaining part is only sin square x plus cos square x of dx, which is clearly 1. Okay, now you know what to do. 2 times of s1 is equal to integration of 1 is x. Finally, what would you get? 3 pi by 8 minus of pi by 8. So which is nothing but 2 pi by 8, that is pi by 4. So finally S1 is equals to pi divided by 8. Okay. So this is a very easy question, but once again, you would need the properties here. Okay. Now this is the second part of the paragraph where we have to find out S2 value. So let's write down S2 actually. S2 is nothing but integral pi by 8 to 3 pi by 8. F of x is same, that is sine square x multiplied by now g2 of x. But in this question, what is g2 of x here? Modulus of 4x minus pi of dx. Okay. So once again, don't fall for the trap that you need to use integration by parts here. The thing is, again go for King's rule. That is, you can replace x with a plus b minus of x. That is 3 pi by 8 plus pi by 8 minus of x, which would mean replacing x with pi by 2 minus of x. So let's do that. S2 is equals to integral pi by 8 to 3 pi by 8. Sine square x obviously changes to cos square x here, and this is nothing but modulus of. So let's do the calculation here. When you replace x with pi by 2 minus of x in 4x minus pi modulus, this would be something like this: 4 into pi by 2 minus of x minus pi. So modulus of 2 pi minus 4x minus pi, which will give you modulus of pi minus 4x, but obviously same as mod of 4x minus pi. So that's the huge advantage here. You can take it as equation number 1, equation number 2. As you can see, it's a simple application of King's rule. So once again, let's add these two. So you get 2 times of S2 is equals to integral pi by 8 to 3 pi by 8 modulus of 4x minus pi multiplied by again sine square x plus cos square x, you will get, right, sine square x plus cos square x of dx. So but we know that the sine square of x plus cos square of x is only 1. So the simple integration which is remaining is pi by 8 to 3 pi by 8 modulus of 4x minus of pi. Okay, so this is your required value. Now once again, after this also many students might go for splitting the limits at pi by 4 and solving both the integrations separately. But what I think is this is a easier method. You can simply draw the graph of mod of 4x minus pi. Okay, we know how to draw the graphs of modulus functions, right? So if you draw the graph of mod of 4x minus pi, this is how it would look like, right? And this is the non-differentiable sharp point pi by 4. So pi by 8 will be somewhere here, and 3 pi by 8 will be exactly in a symmetrical way. 3 pi by 8 will be exactly in this way. And as I told, this is y is equals to modulus of 4x minus pi. So if you put pi by 8 here in this function, you will get y is equals to pi by 2 minus of pi, which is pi by 2. So which means this height here is pi by 2. So you can simply calculate the areas of these two triangles and write down your direct answer. So as I told you, this is the easier method. 2 into S2 is equals to. So since two triangles are there, it would be 2 times of half into base into height. Half of base is pi by 4 minus pi by 8, which is pi by 8, and height would be pi by 2. So let's calculate 2 gets cancelled. Finally, S2 value will be is equals to pi square divided by 8 to 16, 16 to 32. So finally, S2 value is going to be pi square divided by 32. Okay. So whenever possible, you take advantage of graphs while integrating. So if you use splitting the integration and solving, it will take some 2 minutes extra time. So that is why try to be careful here. Okay. Let's take the next question. Now it is a question from JEE Advanced 2015 and completely property based question and potentially very important for upcoming JEE Advanced. So f of x is given to you already, but look at what we need to calculate, that I is equals to integral minus 1 to 2 x into f of x square divided by 2 plus f of x plus 1 of dx. So the main problem is we need to evaluate the two functions separately, that is f of x plus 1. So let's do that. F of x plus 1 is equals to, first case, step of x plus 1, which is also same as step x plus 1. This is when x plus 1 is less than or equals to 2, nothing but x is less than or equal to 1. Another case 0, this is when x plus 1 is greater than 2, nothing but x greater than 1. So you got the definition of f of x plus 1. And now next thing is we need f of x square function. Okay. So f of x square is equals to, this is the step of x square. This is when x square is less than or equals to 2 and 0 when x square is greater than 2. But we know very well, if x square is less than 2, x belongs to clearly minus root 2 to root 2, right? So that is going to be your first interval. This is when x belongs to minus square root of 2 to square root of 2. And the other interval, obviously, x belongs to minus infinity to minus square root 2, open, union square root of 2 to infinity. So clearly you have the definitions of both the functions f of x plus 1 and also f of x square. Now you need to implement this function definitions and evaluate the integration here. Okay. Now this is going to be the very interesting and tricky point. We should know where to split the integration here. So for that we have two main problems. We have step x when you expand f of x plus 1, and also simultaneously we have step of x square. So let's try to understand. We know that step x breaks at all integers like x is equals to plus or minus 2 plus or minus 1 0 and so on. Similarly, we should know where the step of x square will be breaking. So for that, x square should be an integer, that is x square is equal to 0 1 2 3 and so on. So which would mean x is equals to 0 plus or minus 1 plus or minus root 2 and then so on. But what is your required interval of integration? Minus 1 to 2. So let's pick the points which are only required here in the interval minus 1 to 2. So which would mean you have to break at 0, 1, and also because of the step of x square you would need to break at plus root 2 also, right? Now, out of all these points, the only points which we need to break the integration is 0, 1 and root 2, because only these are the points which are lying in between the given interval minus 1 to 2. So, let's try to break the integration. So, I is equals to, first one would be obviously integral minus 1 to 0, and the second one would be 0 to 1, and the third one 1 to root 2, and finally we need up to 2, right? So the final integration is going to be root 2 to 2. Okay, so let's keep in mind we have to put the functions f of x plus 1 and also f of x square while integrating here. So let's calculate step by step. First, minus 1 to 0 x into f of x square. So look at f of x square function. This is in between minus 1 to 0. So whenever x belongs to minus root 2 to root 2, step of x square should be written. So which means it would be x into step of x square whole divided by 2 plus. Now look at the given interval minus 1 to 0. So when in the interval minus 1 to 0, clearly you would have to write step x plus 1 in the place of f of x plus 1, because whenever x is less than or equals to 1, you should replace f of x plus 1 with step x plus 1. So let's do that. Step x plus 1. Okay. So look at the functions and substitute the functions here. Now, between 0 to 1. In between 0 to 1, again, f of x square is not changing, which is again step of x square, but divided by 2 plus. Now when x is in between 0 to 1 also, f of x plus 1 is clearly step x plus 1. Just look at the function definitions I have written here. Based on that I am substituting. Similarly, what about the next one? Now here you have to be careful. This is 1 to root 2, but obviously it is less than root 2, so it is less than root 2. F of x square is step of x square divided by, but 1 to root 2 means it is greater than 1. But look at here, when x is greater than 1, you have to put f of x plus 1 as 0. So that would make it denominator 2 plus 0. Okay. And what about the last case here? Root 2 to 2, which means it is greater than root 2. Look at the definition of f of x square. When x is greater than 2, this one, when x is greater than 2, your function f of x square is directly 0. So that would make x into 0 divided by 2 plus 0 anyhow. So which means the last term is anyhow going to be 0. So this is how you need to split the integration and look at the definitions of both the functions simultaneously. Based on that, you put the proper definitions of the function. Now you know what to do, because I is equals to integral minus 1 to 0. So just think properly. When x belongs to minus 1 to 0, step x value will be minus 1. So that would make the denominator as 2 minus 1 plus 1. Okay. And then what about x square? It will be between 0 to 1, right? So that is why it will be x into 0 of dx plus similarly integral 0 to 1. When x belongs to 0 to 1, x square also belongs to 0 to 1. So that would make step of x square as 0. So it becomes x into 0 divided by 2 plus 0 plus 1 of dx. And then finally, the last part. Third term, when x belongs to 1 to root 2, when x belongs to 1 to root 2, x square would belong to 1 to 2. So step of x square will be 1. So finally, remaining part will be x into 1 divided by 2. So clearly the first term and second terms are also zeros here. So what is the only remaining part in this question? I is equals to integral 1 to square root of 2 x by 2 of dx. Now you know what to do. 1 by 2 into x square by 2, where limits are from 1 to root 2. So if you substitute 1 by 2 times of 1 by 4 times of, this will be 2 minus of 1. That is finally 1 divided by 4. So this is your value of I, which is 1 by 4. Okay. So as you can see, the question might look simple, but how you break the function and split the integration is very, very, very important. As I told, potentially very important. These kind of questions for the upcoming JEE Advanced. Okay. By now, you would have understood how the questions in JEE Advanced will be asked based on definite integration, right? So we have solved almost some last 8 to 9 years of advanced PYQs, right? And along with this one, I have already made two videos of two PYQ questions, which are most difficult from the definite integration as separate videos. You can visit the channel and go check it out. Very interesting questions and most difficult. And so, as I told, these are the three categories which you should focus on. Okay. So, in the upcoming video, I'll go to the next concept for preparation of JEE Advanced 2026. Okay. Thank you.